Hi, today I'll be showing you how we can clear, flip and check a specific bit. To clear a bit, we can use the AND operation. If you remember the truth table of the AND operation, you see that we get the output 0 as long as we pass the number 0 in one of the inputs. For example, let's say I have the variable a that holds the value 5. The number 5 in binary is represented by the digits 1, 0, 1. What if I want to clear this first bit here? If we look at the table, to get the output 0, we need to pass the value 0 in one of the inputs. So, in the first input I have the value 1. All I need to do now is pass the value 0 in the second input. So now we have 1 and 0, we have 0. That way we cleared the bit. So now let's see how this works in the code. Here I have the variable a that holds the value 5, and to perform the AND operation I need to use the %, operator. Let's save the value in the variable a again. All we need to do is to pass the second input to perform the AND operation. In this case we want to pass the value 0 to the first bit, so we need to do this. With this 0 here, I'm saying that I want to clear the first bit, and in the first position I'm passing the value 0. I need to do this because if I do something like this, this will not work. Here I'm saying that I want to clear all the bits, so in this case I would have the value 0, so it won't work. I need to use this syntax. Now let's check the result. Here in the output we have the value 4. That's right, because since we cleared the first bit, we are subtracting 1 from the original value. Now, to flip a specific bit, all we need to do is use the XOR operation. If you remember the XOR truth table, you see that every time we have different input, we have the value 1 in the output, and every time we have the same value in the input, we have the value 0 in the output. Let's say that I have the same variable a that holds the value 5, and we know that the value 5 in binary is 1, 0, 1. Let's say that I want to flip this first bit. All I need to do is to perform an XOR operation passing the value 1. So in this case I have 1 and 1. If we look at the table, we see that when I have 1 and 1, I have 0 in the output. So for the second bit I have 0. I also can perform an XOR operation past the value 1, and now I have 0 and 1. If we look at the table, if I have 0 and 1, I have the value 1 in the output. The same way with the last bit, if I have 1 and 1, I have 0. To perform the XOR operation, we can use the caret operator. So it will be like this. Here, the same way, I'm telling that I want to flip the first bit. Let's see the result. Here, as you can see, I have the value 4 because I flipped the first bit, and the first bit I I'm subtracting the value by 1. To check whether a specific bit is 0 or 1, we need to use the AND operation. If you remember the truth table of the AND operation, you see that we get the value 1 in the output only if we pass the value 1 in both of the inputs. Again, I have the variable a that holds the value 5, and we know that the binary is 1, 0, 1. So now what can I do to check the bits? All I need to do is perform an AND operation. So let's check this first bit. All I need to do is to perform an AND operation passing the value 1. In this case I will have 1 and 1. I have 1. So I know that the first bit is 1. Let's go to the second bit. I perform an AND operation passing the value 1. So now I have 0 and 1. Then I have 0. Then I know that the second bit is 0. Similarly, for the third bit, I can perform an AND operation passing the value 1. And now I have 1 and 1 is 1. So I know that the third bit is 1. To do this, I'll be using a for loop. And now we need to specify the quantity of bits we want to check. In this case, let's say that I want to check 4 bits. It will start from 0. So, and now for every bit I need to perform an AND operation and check whether the result is a 0 or non-zero value. Now let's create the variable that I want to check. In this case, let's say that I have the variable a that holds the value 5. Now all I have to do is for every bit I need to perform an AND operation to check whether that specific bit is a 0 or non-zero value. So I'll be doing the same thing that I did before. Here, if the result is a non-zero value, we know that that specific bit is 1. So let's print it. And if the result is a 0, we know that the specific bit is 0. So let's print it. Now let's see the result. Here I have the binary representation for the value 5. Let's change it. Let's say that I want to see the binary representation of the value 3. Now let's run again. Here I have 1 and 1.